Hi, welcome to the crash course titled Spring Boot Application Integration Testing using Test Containers. Well, in this course, I'm going to show you how we can, perform integration testing using test containers. Well, nowadays, many organizations uses containerized platform for the deployment, right? And let's say if you set up the Jenkins CI pipeline in your production, then you can simply run your test cases in the Jenkins CI pipeline. And in Java, test containers Java library basically helps us to run the integration test cases in a Jenkins CI pipeline using Docker containers. All right. Well, in this course, I'm going to show you how we can do the integration test using test containers. So basically, we're going to deploy MySQL database in a Docker container using test containers, and then we'll execute integration test cases with respect to the MySQL database, which is deployed in a Docker container. Now let's take a look into what is integration testing. Well, as name suggests, integration tests focus on integrating different layers of the application. That means no mocking is involved. For example, here you can see this is again a 3-layer architecture. Alright, controller layer, service layer, repository layer, and repository layer will talk with the database. And this is for employee management feature. Okay, because we have an employee controller, employee service, and employee repository. And basically integration testing means we are going to test the integration of these different layers. We are not going to test a single or individual component. We are going to test the integration of these layers. Okay, this complete flow from employee controller to database. Okay, and we are not going to mock any objects while integration testing. So integration testing means basically we'll test the integration of different layers. All right, consider one more example, user management feature. Well, while implementing user management feature, we create a user controller, user service, user repository, right? And in order to do the integration testing for this feature, we do the testing for all these layers. Okay, we don't test only the single component like user controller. We test the integration of all these components. Okay, similarly login feature. All right, so just remember integration testing means testing the integration of different layers. Okay, and in case of integration testing, we don't have to use a mocking mechanism. Okay, we don't have to use a Mockito framework or any other mocking frameworks. Well, this video is sponsored by my Udemy course. Well, look at here, testing Spring Boot application with JUnit and MySQL. Well, this is a brand new course I have published on Udemy, and in this course you will learn how to do the unit testing, integration testing for your Spring Boot application using JUnit, MySQL, AssertJ, Hamcrust, JSON path, and test containers. So these are the well-known Java frameworks for testing. So in this course you will use all these popular frameworks for testing the Spring Boot application. And basically in this course you will learn how to unit test the repository layer and service layer, and you will learn how to unit test REST APIs. You will learn how to do the integration testing using MySQL database. You will learn how to do integration testing using test containers. You will basically learn a lot of stuff about testing Spring Boot application in this course. And this course has a very less cost or less price, so you can go ahead and grab this course on Udemy. Let's go and let's kickstart this crash course by looking into what is test containers. Well, test containers is a well-known Java library that supports JUnit test cases. Okay, and if you can consider this architecture diagram over here, typically we write the integration test with respect to the local database. In our case, let's say MySQL database. Okay, so basically we write the integration test and we run with respect to MySQL database, which is installed in a local machine. But the problem here is the integration tests are tightly depends on the MySQL database, which is installed locally, isn't it? And every time we want to run the integration test cases, then we have to install MySQL database. Let's say if you are developing a big enterprise application, then your enterprise application may depends on various external services. For example, let's say databases, message queues, Redis, okay, RabbitMQ, Kafka. Alright, so before running integration test, you need to install all these external services. Then only you can able to run the integration test cases, right? So this is common problem while executing test cases, that is integration test cases. And this is the basically a common problem, right? And test containers is a solution for this problem. Well, basically test containers, what it does, it allows us to use a Docker container in JUnit test cases only. Well, if we use test containers with JUnit test cases, then test container will basically deploy a Docker image in a Docker container. For example, let's say our integration test cases depends on the MySQL database. Then these test containers will pull MySQL Docker image from the Docker hub, and then it will deploy in a Docker container, so that we can able to run our integration test cases with respect to MySQL database. This is awesome, right? We don't have to install MySQL database in our local machine. If we have a Docker installed, then we can simply use test containers to deploy the MySQL Docker image in a Docker container, and we can able to run our integration test cases. Let's see how we can do this step by step. Well, before creating Spring Boot project from the scratch, let's quickly take a look into what is test containers. Well, test containers is basically a Java library that supports JUnit tests, providing lightweight throwaway instances of common databases, Selenium web browsers, or anything else that can run in the Docker container. Well, basically test containers is a Java library, and that allows us to use a Docker container in JUnit test cases itself. Okay, so we can simply give the Docker image name to the test containers. Then test container will basically pull that Docker image from the Docker hub, and then it will deploy in a Docker container, so that we can able to run our JUnit test cases with respect to database. This is awesome, right? We don't have to install any external services, for example MySQL database or RabbitMQ or any external services. Alright, great. Well, test containers make the following kinds of tests easier. Well, you can use test containers with data access layer integration test, application integration test, acceptance test, and much more. Because these test cases are depends on external services, so you can use test containers to deploy these external services in a Docker container. Alright, let's take a look into the prerequisites. Well, Docker is a prerequisite basically. If you want to use test containers, then you have to install Docker in your machine. Let's say if you want to run your integration test cases in a Jenkins CI pipeline in a production, and it is common that most of the organization uses Docker in a Jenkins pipeline to deploy the applications, right? And yeah, so Docker is kind of a prerequisite for test containers, and make sure that before using test containers you have to install Docker in your machine. Or if you want to run your integration test cases on production, then make sure that Docker is available in a production. Next, Maven dependencies. Well, if you are using Maven project, then you can go ahead and grab this test containers dependency. If you are using Gradle, then you can go ahead and grab this Gradle dependency for test containers. Alright, and you can see here features. So if you want to learn more about test containers, then you can go ahead and dive into these features of test containers. And you can see the modules. Well, you can see there are a lot of modules: Kafka containers, Docker Compose module, Azure, Google Cloud, okay, local stack, RabbitMQ. Well, basically test containers supports all these cloud and other modules. And in databases section, you can see here a lot of databases, right? Well, we can use test containers to deploy these databases as a Docker image. This is awesome, right? Test container supports a lot of databases, right? And a lot of modules, isn't it? That's why test container is a very popular Java library which we can use to directly use Docker containers in JUnit test cases. Okay, so this is quick overview of test containers. Now what we're going to do is we're going to quickly create a Spring Boot project, and then we write the integration test using test containers. Well, let's head over to start.spring.io. This will bring up Spring Initializer, and go ahead and select Maven project and then language Java. Spring Boot version 2.6.2. And then let's go and let's fill up the project metadata over here. Let's say group ID net.javaguides.springboot. Well, I'm going to give group name something like net.javaguides.springboot. So you can give any group ID that you want. And here artifact ID is nothing but our project name. So let me give something like SpringBoot Testcontainers demo. Okay, so name is nothing but artifact, and description, let's give demo project for SpringBoot and Testcontainers. And package name, let's keep net.javaguides.springboot. Okay, and packaging, let's keep jar as a selected and Java 11. You can choose Java 17 or 8 as per the Java installation on your machine. And go to the dependency section over here, and here we're gonna choose Spring Web dependency. Apart from that, we are going to use Spring Data JPA dependency. We are going to develop a repository here, so we're going to use Spring Data JPA dependency, and we are going to use Lombok library to reduce the boilerplate code. And let's go and let's use MySQL driver. Alright, and then yeah, that is pretty much. So make sure that you have selected Spring Web, Spring Data JPA, Lombok and MySQL driver, and then go ahead and click on generate over here. So this will generate Spring Boot application as a zip file in a file system, and go ahead and open in a folder and just extract it. Alright, and let's open IntelliJ IDEA and let's import this project. So I am going to open the IntelliJ IDEA over here, click on open and go to the folder where the application is extracted. So I am going to go to the downloads folder over here, and Spring Boot Testcontainers demo, select it, click on open. Alright, so you can see resolving dependencies of Spring Boot Testcontainers demo application. So mine will basically take a couple of seconds to resolve all the dependencies. Let's wait a couple of seconds. Well, you can see here Spring Boot application is successfully imported in the IntelliJ IDEA. Now what we'll do, we'll quickly create a packaging structure for our project. So go ahead and right click, new, and then choose package. Let's give package name as entity. Within entity package we keep the JPA entities, and let's go and let's create one more package. Let's call it as a repository, and again let's create one more package. Let's call it as controller. Alright, next what we're gonna do is we're gonna configure MySQL database details. So go ahead and open application.properties file over here and just type the property spring.datasource.url equals to jdbc:mysql and localhost. So we are going to connect to the local MySQL server, that's why here localhost, and the port 3306, and database, let's say demo. Alright, and we are going to disable the SSL. So let's have a property SSL, use SSL equal to false, and let's configure username and password here. spring.datasource.username root, in my case the username is root, and similarly let's do it for password. Alright, so make sure that you have to change username password as per the MySQL server installation in your machine. And let's go and let's configure Hibernate Dilate as well as DDL Auto Hibernate property over here. Alright, so look at here the Hibernate Dilate for MySQL database, and this is the DDL Auto property. So this will create a table automatically. Okay, great. Now what we're going to do is we're going to create a JPA entity. So go to the entity package over here, right click new and then choose Java class. Let's give entity name something like student. Okay, and let's declare the fields something like private, long ID, and then private string first name. Alright, and similarly let's create one more field as a last name. Okay, and let's go and let's create one more field, email. Perfect. And let's annotate this class with add setter annotation to create a setter methods for these instance variables, and let's also have a getter annotation. So this is basically a Lombok annotation to generate a getters method for these private instance variables. Okay, now what we're gonna do is we're gonna use add builder annotation to have a builder pattern for this student class, and we can also use add all argument constructor to create parameterized constructor for this class. Let's have no argument constructor. Okay, now we have created a class with getter setter methods, builder pattern and constructors. Now let's make this class as a JPA entity. In order to do that, let's go and let's use JPA annotations. Let's use add entity annotation and also use add table annotation to specify table details over here. Let's say the table name is students. Okay, well, here is a typo. Now what we're gonna do is we're gonna specify the primary key for this table. So let's go and let's use add ID annotation and also specify the primary key generation strategy. So let's have a strategy something like add entity generation type add entity. So this will auto increment the column in a table. All right, and let's go and let's configure the column name for these fields. Let's say add column annotation over here and just give name to the column something like first name. Okay, and let me copy this and go ahead and similarly do it for last name. So this is something like last underscore name. Okay, let's change from first name to first underscore name. Alright, we have created a student JPA entity. Now what we're going to do is we're going to create a JPA repository for student entity. So go to the repository package, right click, new and choose Java class and choose interface, and let's give repository name something like student repository. Hit enter, and let's go and let's extend student repository interface from JPA repository. And look at here, JPA repository takes two arguments, type of the entity and type of the primary key. So in our case we are going to create an entity for student, so go ahead and pass student as a first argument. Alright, and second argument is the type of the primary key, that is long. Okay, and we no need to annotate this interface with add repository annotation because JPA repository implementation class will take care of that. Now we have created student repository. Now let's go and let's create a REST API which will call student repository methods. So go to the controller package, right click, new and choose class. Let's give class name as StudentController. Alright, and let's annotate this class with add REST controller annotation to make this class as a Spring MVC controller which will able to handle the HTTP request. And let's also annotate this class with add request mapping annotation to provide a base URL for this controller. Let's say base URL something like /API, and also mention students. Alright, and let's quickly create one REST API over here. Before that, let's inject student repository. So we're not going to create a service layer because this is just a demo to showcase how we can use test containers for integration testing. If you have a requirement to use the service layer for business logic, then you can go ahead and create the service layer. Alright, and let's create a REST endpoint public which returns a student, and let's call it as create student. Okay, and just pass student object as a method argument, and then simply return a student repository dot call save method to save the student object. And now we have created a method, right? Let's make this method as a REST API by using annotation, that is add post mapping annotation. It's pretty simple, isn't it? Let's use add request body annotation. Alright, and this will basically map HTTP request directly to the student object. And let's go and let's annotate this method again with @response status annotation, and we need to provide HTTP status as created. Okay, so this is the REST API to create the new resource. So we have to specify HTTP status as created. Alright, just save it. We have created a REST API to create a student. Alright, great. Next, let's go and let's create one more REST endpoint, that is get all students REST endpoint. Let's create a method first, public, and then it return a list of student, and let's say get all students is the method name. Alright, and just return call student repository and then call final method. So this will return a list of students, and go ahead and annotate this method with @get mapping annotation, so that this method will handle HTTP GET request. Okay, this is pretty simple. We have created get all students REST API. Alright, great. So now we have created a base for integration testing. We are going to basically write an integration test for StudentController. Okay, great. Now it's time to create an integration testing. Well, go to the test package, and here what we're going to do is we're going to write the integration test. So we have already annotated this class with @SpringBoot test annotation. Well, here @SpringBoot test annotation is very useful for integration testing, because @SpringBoot test annotation will load a full application context. Full application context meaning it will load all the Spring beans that is available in the Spring Boot application. Okay, so it will load full application context so that we can able to do the integration testing of different layers of the Spring Boot application, isn't it? And this @SpringBoot test annotation provides different options to run the integration test cases. For example, it will provide the embedded server with random port to deploy this application and do the integration testing. Okay, so ultimately this @SpringBoot test annotation will invoke internally the main entry point class. Okay, and this main entry point class will deploy our Spring Boot application in an embedded Tomcat server, right? Now let's go and let's write the integration test case. Well, just get rid of this code and write the JUnit test case over here, public void, and let's give integration test name something like basically we follow a BDD style. Okay, given students. Okay, we are going to save multiple students first in a given section, and then comes when. So basically in a when we call the get all students API, right? And then this will return list of students. So this is typical naming convention that I follow to give name to the JUnit test cases. So this is basically a given when then format. Okay, so this is basically a BDD style, behavior driven development style. Alright, great. Now within this method we are going to write the logic. So before that, let's annotate this method with add test annotation, and make sure that you choose add test annotation from JUnit framework. Now we divide this test into three parts: given, and then when, and then. In a given section we basically prepare the setup or the precondition, okay, and in a when section we perform the action meaning we perform the actual testing, and in a then section we basically verify the output. Okay, so in a given section basically we are going to create a couple of students and we will save those students in the database table, and in a when section we are going to call a get all students REST API, which will fetch all the students from the database, and in a verify or in a then section we are going to verify the output. So what I'm going to do is I'm going to create a list here and of type student, okay, and then let's call it as students, and here I'm going to create a list of student objects of, and then I'm going to create student object over here. I'm going to use builder pattern. Perfect, we have created two students object. Okay, so first one is Ramesh and second one is Tony. What we're going to save this student object to the database. In order to do that, we're going to first inject student repository over here. We're going to use add annotation to inject the student repository. Okay, student repository, and go ahead and use this student repository and call its method, that is save all, to save the bulk of student objects. That's it. So in a given section we have done the precondition, that is we have saved a couple of student objects into the database, and in a when section we are going to make a REST API call. Okay, for that we're going to use mock MUC object. So let's go and let's auto mock MUC object. So go ahead and use add annotation over here, and let's go and let's use mock MUC object. Okay, so in order to call the REST API, or in order to do the integration testing of REST APIs, Spring framework basically provides mock MUC class which we can use to call the REST API. And in order to enable this mock MUC class, we're going to use annotation, that is add auto configure mock MUC. Okay, great. Now we are good to use mock MUC class object. We'll go to the when section again, and then here simply call perform method, and within a perform method we're gonna call mock MUC request builders class. It provides different methods like post, get, port, delete. So we can use these methods to call the respective REST APIs. We're gonna call get all students REST API in this case. So let's go ahead and call get method and then provide the REST API URL here, that is API/students. Okay, this will provide a list of student objects. And what is the compilation here? Here it says unhandled exception. So go ahead and throw the exception from this method, and this perform method returns a result actions object, right? So go ahead and take the response of this method in a result actions object. Let's call it as a response. Now let's go and let's verify this response in the then section. So go ahead and call the response object, and then we're gonna call and expect method to just verify the expected result with the actual result. And this method expect a result matcher. So just call its implementation, that is mock MUC result matchers, and it has a method called status. Okay, and this get all students API returns a status code OK, right? So we're gonna call OK method to check the HTTP status OK, isn't it? Great. Now we have verified the HTTP status of the response. Next we're going to verify the size of the list that we get in the response. Well, here in a given section you can see we have saved two students object into the database, and we are sure that this get students REST API returns two students object from the database, right? Now here what I'm going to do is we're going to call again and expect method. Alright, and we're going to again use mock MUC result matchers, and this has a JSON path method, and look at here, JSON path method expects expression and matcher, these two parameters. So go ahead and call this, and here we're going to pass the JSON path expression, that is dollar meant for a whole complete JSON structure. Okay, and we can see the JSON structure size by using size method. And here we are going to basically use a second parameter as core matchers class from Hamcrust. It provides is method, so we can use is method to just check the expected result with the actual result. Okay, in this case this is the expected, and what is the actual? So actual is the size of the students, pass students. Okay, this is how basically we write the statement to verify the response of the REST API. So here basically we are using JSON path method to verify the JSON size with the actual size. So here actual size we have given students.size, because in a given section you can see we have saved two students object, and we are sure that get all students method returns two student object, right? That is what we are verifying here. We are just simply verifying the size of the JSON that we got from the response, isn't it? So this is how we write the integration test to test get all students REST API. Now we are good to run the integration test case. Before that, one more thing we want to do is we want to create a database in a MySQL server, because in application.properties file we have configured demo database, right? In order to connect our Spring Boot application with demo database, we should create this demo database in a MySQL server. Well, let me go to the terminal and let me quickly connect to the MySQL database. So here I am basically using terminal. You can use MySQL Workbench if you have MySQL Workbench. And let me create a database, create database demo. Perfect, I have created demo database. Now we are good to run our integration test case. Now let's go and let's run the integration test case, and let's see how this works. And there we go, the JUnit test case passed. It means that the integration test case that we have written is working as expected. And if you want to run this JUnit test case with a clean database, then you can go ahead and change one property. So let me show you. Go to application.properties file, and instead of update you can have a create drop value for this property. So this will basically create and drop the table each and every JUnit test case execution. Okay, great. Now what we have done, basically we have created integration test for one REST API, that is get all students REST API. Now it's time to understand what is the problem with this integration test and what is the solution for this problem. Well, the problem we can see here, this integration test depends on MySQL database, right? And let's say in your Spring Boot application you may have a different external services instead of only database. For example, you may have RabbitMQ, you may have Kafka, you may have Cassandra, CouchDB, right? So our basically integration test cases depends on all these external services, right? And in order to solve this problem we can use test containers, right? So instead of installing all these external services, we can simply use test containers to deploy the external services as a Docker container, and we simply run our integration test cases, isn't it? Now let's go and let's see how we can add test containers in our Spring Boot application, and how we can use test containers to run our integration test cases. Well, in order to add test containers in our Spring Boot application, let's head over to the browser and let's go to the official website of test containers. It is testcontainers.org, and go to quick start here and JUnit 5 quick start, and here basically we need to grab the dependencies. So go to Maven here, and you can see these are the couple of dependencies we need to add. Okay, and you can see here these are the JUnit 5 related dependencies: Jupyter API, Jupyter Params, Jupyter Engine. And these are the JUnit 5 dependencies are already provided by Spring Boot starter test dependency. That's why we are not going to use these three dependencies, and these are the couple of dependencies that we are going to use. Okay, just grab these two dependencies, and you can see here this is the dependency that provides the integration of JUnit with test container. Alright, so just grab these two dependencies. Grab meaning just copy these two dependencies and go to IntelliJ IDEA and go to pom.xml and just scroll down and go ahead and add these two dependencies. Okay, and we need one more dependency. So go to again the official documentation page, and we are going to basically install MySQL as a Docker container, right? For that, go to the module section over here, databases, and go to MySQL module, and we're going to use Maven dependency of this module. So just copy this dependency and go to IntelliJ IDEA again and just paste it here. Alright, and save it, and you can see here Maven icon. So go ahead and click on this to load the Maven changes. So Maven will basically download all these newly added dependencies. In order to confirm this, what you can do, you can go to the external libraries over here and you can confirm. For example, just scroll down and you can able to see here test containers dependencies are added. Okay, it means that we have added test containers support in our Spring Boot application. Alright, now we are good to use test containers. Well, go back to the test class. Now let's go and let's use test container provided annotations to integrate JUnit 5 with test containers. Well, we need to provide extension in order to integrate test containers in JUnit 5. So in order to do that, go ahead and annotate this class with @testcontainers annotation. Well, @testcontainers annotation is basically an annotation. It internally provides an extension to integrate JUnit 5 with test containers. For example, if you can dive into this annotation, you can see this annotation internally uses extension, that is test containers extension. So this extension help us to integrate test containers with JUnit 5. Okay, great. Now we have integrated JUnit 5 with test containers. Let's go and let's create private field here. That is, we're going to create MySQL container instance here. MySQL container equal to MySQL container, and make sure that you should make this container object as a static, so that this object will be shared between multiple test cases. Okay, so if you don't declare this object as a static, then what will happen? This container will start and stop after each and every test methods, and yeah, so it will take a lot of time if it starts and stops before each and every test, right? That's why we just make this object as a static, so that it can be shared between multiple test methods. And again, you can see MySQL container. So we are going to deploy MySQL database in a Docker container. That's why we are using MySQL container instance over here. And this is deprecated because we need to pass a Docker image name to this constructor. And by default, it will take a Docker image with some version. You can see 5.7.34. I guess this is old version, that's why it is deprecated. We have to manually specify the Docker image name. Okay, let me go ahead and let me pass the Docker image name, something like mysql.latest. Well, in order to check the Docker image, what you can do, you can go to the browser and just search for Docker Hub. All right, just type Docker Hub and go to Docker Hub website, and here just type MySQL and just hit enter and go to official image and scroll down and you can see here supported tags and respective Docker files link, and these are the Docker image tags, and you can choose the Docker image as per your requirement. You can specify the version or tag. In my case I am going to use the latest. Okay, you can see MySQL latest. If you want to use 8.0 then you can specify 8.0. so in this example let's keep MySQL latest. Now what will happen basically when this instance will be created? Well, basically test containers will pull this Docker image from the Docker hub and it will deploy in a Docker container. That is awesome, right? We don't have to install MySQL database in our local machine. If we have a Docker installed in our machine, then we can simply use test containers to integrate a Docker containers in a JUnit test cases itself. Alright, now this test container will pull this Docker image from the Docker hub and it will deploy in a Docker container, so that this integration test case can be executed with respect to the database which is deployed in a Docker container, isn't it? And in order to make this instance life cycle methods to be managed by add test container, we're gonna use add container annotation. Now once we annotate this object with add container annotation, then add test containers annotation will manage the life cycle of this Docker container. Alright, life cycle method meaning this will basically start the container and stop the container. Okay, great. Now we have created MySQL container. This will load or it will pull the Docker image from the Docker hub and it will deploy in a Docker container. Now what we're gonna do is we're gonna see what is the default database username password this MySQL container uses behind the scene. So in order to fetch the default username password and JDBC URL, what we can do is we can put some sysout over here and print some data. So I'm going to print some data, for example MySQL container dot get database name, and put again one more sysout here, MySQL container dot get password. Okay, and one more sysout, MySQL container dot get username, and let's have one more sysout, MySQL container dot get JDBC URL. Alright, so I just want to show you what are the default database name, password, username, JDBC URL that this test container internally uses to manage this MySQL database, isn't it? Great. Now if we run our integration test case, it will able to connect to the MySQL database which is deployed in a Docker container. Well, before running these integration test cases with respect to test containers, make sure that your Docker a desktop is running in your machine. For example, I just started Docker instance and you can able to see Docker's desktop is running on my operating system. Alright, now I'm good to run the integration test case. So let me run the integration test and let's see how this works. And look at here, test container will basically pull this MySQL latest Docker image from the Docker hub and it will deploy in a Docker container. Right, so initially it will take some time, but later on it won't take time because initially it need to set up the things, right? And you can able to see here test case passed. It means that we have successfully executed integration test with respect to the MySQL database which is deployed in a Docker container. And let me show you the default database name, password, username and all those stuff, right? So go ahead and click on this JUnit test case and you can see here by default test container uses database name as a test, password as a test, username as a test and JDBC URL. Okay, so whenever test container pull the Docker image, that is MySQL Docker image from the Docker hub and it will deploy in a Docker container, then by default it will use all these details. Okay, by default the database name test, username test, password test. Okay, and this is the default JDBC URL. Alright, Great. Now what we can do is we can observe the problem with this code. Well, in our Spring Boot application we have only one integration class, right? And let's say in your Spring Boot application you create a multiple integration classes, then you have to create a multiple instances of this MySQL container class, right? So in order to avoid this problem, what we can do is we can create one abstract class and we can make this MySQL container as a singleton, so that other integration test classes can simply extend abstract class and can reuse this MySQL container singleton instance. Alright, so basically it is best practice to share this MySQL container instance with all the integration test classes. We don't have to create a separate MySQL instance for each integration test classes. Okay, now let's see how we can do that. Well, if you can go to browser and you can just search for singleton test containers. So basically in a documentation they have mentioned like singleton containers pattern. So this is the important, guys, this is the pattern that we have to use to make this MySQL container as a singleton, so that other integration test cases can reuse it. For example, look at here the code snippet. We need to create an abstract class and we need to make this MySQL container as a singleton by using static block, and the rest of the integration test classes can simply extend this abstract class and can reuse this MySQL container instance. Alright, so we are going to use similar to this example. So let's go and let's head over to the IntelliJ IDEA and let's create one abstract class. So let me copy this class name because we are going to create the same class name. So I'm going to create a class, let's name it as abstract container base test, and here we are going to create a singleton instance, right? For that, in case of creating a singleton object of the class, we first make a field as a static. Alright, this is a MySQL container, and let's have a naming convention for this class object as my_SQL container, and let's use a static block over here to create and initialize the object of this class MySQL container equal to new MySQL container, and I'm going to pass docker image name is MySQL:latest. Perfect. Now we're going to start explicitly this container, right? So go ahead and call the start method. If we start this container explicitly, then we don't have to use the test containers annotation. That is, you can see we have annotated this class with add test containers annotation, right? We can simply remove this annotation because we are explicitly starting the MySQL container instance. Alright, and here we can simply remove this piece of code because this is not going to we are not going to use it because we have already created the instance in abstract class. So again, get rid of this sysout statements, and here just extend the abstract class, that is abstract containers base test class. Alright, that's it. And whenever you create integration test classes in your project, then you can go ahead and simply extend this class and you can reuse this MySQL container instance. Alright, so let's go and let's run the integration test case and let's see how this works. Well, I'm going to run this integration test case now. And there we go, the test passed. It means that we have successfully used singleton containers pattern to optimize this code. Okay, we have basically made MySQL container instance as a singleton so that it can be used in multiple integration test classes. Alright, this is a best practice actually. The test containers team suggest this approach. Okay, great. Well, let me recap what we have done in this crash course. Well, we have basically understood a quick overview of test containers, and then we have created a Spring Boot project, and then we have created a couple of REST APIs, and we have created an entity repository, and then we have created integration test with respect to the local MySQL database, and then we have seen what is the problem with using local MySQL database, and then we have added test containers as a solution, and then we have integrated test containers in our Spring Boot application, and then we have used Singleton containers pattern to optimize the code, and finally we ran the integration test with respect to the test containers. And yeah, so we have successfully ran that integration test with respect to the MySQL database, which is deployed in a Docker container. All right, we have understood pretty much about how to use test containers to perform integration testing in a Spring Boot application. All right, great. Well, if you want to learn more about testing Spring Boot application with JUnit and Mockito, then I am going to suggest you my course that I have published on the Udemy, that is testing Spring Boot with JUnit and Mockito. So in this course, you can learn how to write the unit test cases and integration test cases for Spring Boot application using JUnit, Mockito, AssertJ, Hamcrust, JSON path, and test containers. Well, basically you will learn how to write the integration test for a repository layer components, service layer component, and controller layer components, and you will also learn how to write the integration test cases with respect to the local database, with respect to the test containers. Alright, you will learn a lot about testing Spring Boot application with lot of popular frameworks like JUnit, Mockito, AssertJ, Hamcrust, JSON path, and test containers. Alright, so just go ahead and enroll this course. I'm damn sure that you will able to learn a lot about testing Spring Boot application, and I have used industry standard approaches. Okay, you can just go through these points and you can just go through the preview videos. You can able to understand how I have organized this course. Okay, great. All right, thanks for watching this crash course, and yeah, I will see you in next video.